I know why you're here. You shouldn't have been here anyway, but you're here, so what are we gonna do? Well, hi, hello, good morning probably. It's probably late in the morning or probably early afternoon when you're watching this. I know for a fact what time you're watching this, but anyway, or maybe late at night. Anyway, I hope you guys are doing well, and this one is basically a crash course on your PETA for the end time, but this time around we're gonna make sure that you're gonna be able to do your part, and we're gonna discuss the PETA shortly. At the same time, how you can create word problems, so you can skip right into it if you want to when you're clear with everything that's going on. But if you want to be refreshed and to know what to do, you may listen or watch the presentation, and then afterwards we'll create word problems together. With that being said, let's just jump right into it. Okay, so we're gonna create 5 different word problems today. And one of the most important things that you need to do in order for you to create a word problem is to start with the answers. This is the same thing that I have been mentioning on how to actually create word problems. So, for example, we would like to start with having a word problem dealing with the area of a rectangle. So for this video, I'm gonna use characters from my favorite group, which is Red Velvet. So at least I can do something that I actually like also. So for example, what I want to do here is a word problem involving rectangles and its area. So we will start with what kind of object we would like to be rectangular. Let's say that the story goes as if they are trying to look for a rectangular box or rectangular table or rectangular pool and so on and so forth. Since their name is Red Velvet, I guess they're planning to buy a red fence for a rectangle. What? Wait, I'm trying to think now. Okay, let's say swimming pool. So we'll have a rectangular pool as our focus for this word problem. And then the next thing is that we're gonna think of the answers. Basically, what should be the measurements or the dimensions of said pool? Pool, I mean. So let's say the dimensions are as follow. Let's have the length of said pool as, let's say we have 10 feet, and then the width as 8 feet for the rectangular pool. So with this out of the way, we can actually start working with the concept of a rectangle. So we know that when we're dealing with the area of a rectangle, the formula is simply length times width. And the length here is 10, and then the width is 8. So therefore, the area is 80 feet squared. So now that we have dealt with the answers, we can start creating our word problem. So let's say that Red Velvet is thinking of having a pool I'm sorry, it could be rectangular swimming pool, I guess. Rectangular pool. I'm sorry if I just write that this way. I cannot undo the writing. So, Red Velvet is thinking of having a rectangular pool whose area is 80 square feet or 80 feet squared. So the next part that you have to do, now that you have written the area of said rectangular object, you will create a relationship between the length and the width. How will you write 10 feet and 8 feet? Like, what's their relationship? So basically, we could say that we have if the length is 2 feet longer than the width, what are the dimensions of the pool? And that is actually a word problem already. So with this being written, we already know that we are looking for the dimensions. And yes, we know the answer basically. Since you're creating your own word problem, you know the answer. So, but how will you get there? So the most important part first is to know what you need to do with the given. Since it's area, so we should make use of the formula. Area is equal to length times width. And then from there, we should know our representation. So representation basically is what variable will you use in order to represent it. So let's say that the width is W, and since we said that the length is 2 feet longer than the width, we can say that the length is equal to W plus 2. Again, how did this happen? The width is W, and since the length is 2 feet longer, so it's plus 2. So we can continue with our solution. Area is equal to length times width. And since we know that the area is equal to 80 feet, we substitute that. And our length is W plus 2, and our width is W. So we multiply it together. We'll have 80 is equal to W times W is W squared. 2 times W is 2W. And again, we need to have the terms all together in one side, so we subtract 80. You can also do transposition if you're used to that. So you'll have W squared plus 2W minus 80 is equal to 0. So now we have this general trinomial. And from here on out, we can work on this one to get the value of W. So we will have this general trinomial. And you're like, sir, ang hirap. How do I factor it? Again, do not panic. You're the one who created this word problem. So you go back to your answers, 10 feet and 8 feet. So basically, that will be your factors. So W times W equal to 0. One should be 10, the other should be 8. And now, which one should be positive? It should be 10. And 8 should be negative. So 10 times negative 8 is negative 80. 10 plus negative 8, that's positive 2. Do not panic here. How will you know the sign of the higher number? It depends on the middle term. Okay? From here, we can now do equating by 0. Basically, each factor will be equal to 0. W plus 10 equal to 0. W minus 8 equal to 0. Subtract 10 to both sides for your first factors. You'll get W is equal to 10. Here, add 8 to both sides. Wait, are we correct? Wait. 2W. This is negative 10. Yeah, I forgot the negative 10. We add 8 to both sides here. So W is equal to 8. And always remember, you cannot have a negative measurement for your length or width. So the correct answer is W is equal to 8. So with that, you can substitute as width is equal to 8 and length is equal to 8 plus 2, and you'll get 10 feet. So that's it. So you now have a word problem involving rectangles, and factoring is shown. Again, this is the important part of this activity or of this task for you to do factoring. Without factoring, well, you're gonna have to repeat it all over again. So this is an example of a rectangular word problem. So let's go with another one. This time, let's go with the area of a square. So our next character here is Yeri. And let's say that Yeri is planning to create or buy a square table. And she's trying to measure the top of it, or maybe a square box. So let's say or maybe something similar to that. So, okay, I think we'll go with the square box for Yeri. And then now, the beauty about a square is that when you're dealing with it, there's only one measurement for it. Like given side, think of a measurement for a box. So it should be realistic. Like let's say that the box is 10 centimeters, for example, each side of it. So the area of a square, the formula for that is simply side times side. So if the measurement of the given side is 10 centimeters, you'll have 10 times 10, that's equal to 100 centimeters squared. So we can have that already. So it's your freedom on how you would word it, but basically you can say that, for example here, let's say that Yeri is planning to create to sorry to create a square box if the area of the square cover, basically to be realistic, we're just looking at the cover, like the top, the square top of the square cover or square top is 100 centimeters squared. What should be the measurement of each side? And you might see like, sir, what's the difference between a square word problem in relation to a rectangular word problem? In the square word problem, you're not comparing the sides, because always remember that for a square, all sides should be equal. Okay? All sides are equal for a square. That's why we don't have like, if the width is like this and that, we don't have that here. Okay? So to continue with this one, so what we're looking for is the value of the side. And for representation, let's use letter S, just to not make it that complicated anymore. So again, the formula is area is equal to side times side, or S squared. You can have that already. So with that, the area is 100 is equal to S squared. Subtract 100 to both sides so that everything will be in one side of the equation. You'll get S squared minus 100 equal to 0. And from here, it's one of your favorite examples of factoring. This one is a difference of two squares. So S squared minus 100 is equal to 0. The factors are as follow: S plus 10 and S minus 10. And again, this is equal to 0. Let us now equate it to 0. You'll have S plus 10 equal to 0, S minus 10 equal to 0. Oops. So subtract 10 to both sides. You'll get S is equal to negative 10. Add 10 to both sides. You'll get S is equal to 10. And again, we make use of the positive value. So S is equal to 10 centimeters. So each side of the said square top should be 10 centimeters. The important, again, part of this activity is for you to do factoring. So make sure you will be able to show this part of your solution. So that's how it works. Okay? So now we're done with the area of rectangles and squares. Now let's deal with consecutive pages. Ayan. So let's say that we have two characters this time. We have Joy and Irene. And let's think of a different book that they might read. So let's say they're reading a certain book. Let's say that the book is, what kind of book will they read? I think they've read the book Kim Ji-young, born 1982. So let's have that as our given, since we're dealing with the book. I haven't read this book though, but I'm planning to read it by this year. But I've heard that Irene read this, so why not include it in the story? So let's say that this is the concept or the book that we're gonna have. So what do you do when you're dealing with consecutive pages? The word is consecutive, meaning to say that the pages should be next to each other. So let's say that the favorite part of Irene is page 12 and 13. Let's just say that. So what is the product of said pages? Product of the two pages. So let's do that. So the product of the two pages, 12 and 13, what's the answer there? Wait. My brain is lagging. Can I do this mentally? Okay, I think it's 156. So from here, we can now create a word problem. Let's say that Irene is making Joy guess her favorite consecutive pages in the book Kim Ji-young, born 1982. If the product of the two pages is 156, what page is Irene's favorite? So basically, you don't have to panic here when we're dealing with the word, with the word consecutive. It basically means that they are next to each other, right? Just like in books. So basically, when we do representation for that, let's just use the letter P for page. So, wait, my spelling is getting worse. Representation. So let's say that the first page is letter P. So the second page should be what? Basically, the second page will be equal to P plus 1. Why is it P plus 1? Because, for example, page 1, what's next? Page 2. So the difference between the two numbers is 1. That's why it's P plus 1. Okay? So let's start with the solution. Since the word is product, so we're going to have the product, which is 156, is equal to the first page and the second page, which is P times P plus 1. Basically, distribute P, you'll get 156 is equal to P squared plus P. Subtract 156 to both sides to put them all together in one side of the equation. You'll get P squared plus P minus 156 is equal to 0. From here on out, you will simply do factoring. And again, you created this word problem, so you don't have to panic. Wait, why am I receiving messages? So basically here, this will be factored out. You'll get P plus 13, and we're going to multiply that to P minus 12, and then it's equal to 0. You'll be wondering, sir, why is 13 positive? Because your middle term is positive, and 12 is negative because, again, your last term is negative. Where did we get 13 and 12? It's the one that you started with. That's why when you're creating word problems, you don't have to panic because you're the ones who created it. So now let's go with equating each factor to 0. We'll get P plus 13 equal to 0. P minus 12 equal to 0. Subtract 13 to both sides in this one. You'll get P is equal to negative 13. Add 12 to both sides here. You'll get P is equal to 12. So that means that your first page is 12. First page is 12. Second page is 12 plus 1, and that is equal to 13. That's what we started with. So we now have a word problem. Let's now go with some more. This time around, let's deal with finding the ages. So with finding the ages, the good thing about this is that you can make use of real life examples like how old these people are, and you can work with that already. At the moment, I forgot their ages, but let's just say that Wendy, I think Wendy is somewhere in 26. I think is 26 years old. I think, I don't know. I'm not sure. Irene is 30, I think, or 31. So let's just say that. So the ages are as follow. Wendy is 36, Irene is 31. So what we can do so that we can still apply factoring, we have to make sure that we're gonna have multiplication as our operation. So what we will do is we will multiply their ages. So 26 times 31 is 806. So product of their ages is 806. Okay. So again, why are we multiplying it? Because if we don't multiply, if we just add them, the relationship or the solving will not involve factoring polynomials. So what kind of word problem can we do here? So let's say that Irene and Wendy, sorry Wendy, don't hate me, love you. Irene and Wendy are making their fans guess their ages. So what's next here is we will create a relationship of their age. Since Irene is 31, Wendy is 26, we can say that Irene is 5 years older than Wendy. And then this is where we will include the product. If the product of their ages is 806, how old are they? So that's it. We have created a word problem. And from here, let's have the representation. So for the representation, we'll start with Wendy. So Wendy will be W because it's a dub for the Reveloves. Wait, what happened? Representation. Wendy is W and Irene is what? W plus 5. Why is Irene W plus 5? Because again, Irene is 5 years older than Wendy. So we can now create a word problem. So let's say that we start with the product, which is 806. Representation is W and W plus 5. So we distribute the W, we'll get 806 is equal to W squared plus 5W. Subtract 806 to both sides of the equation. We will get W squared plus 5W minus 806 is equal to 0. From here on out, we can now do factoring. So the factors could be simply W plus 31 and then W minus 26, and this is equal to 0. And again, you don't have to overcomplicate this because we made the word problem. It's here, 31 for Irene, 26 for Wendy. Why is 31 positive? Because your middle term is positive, so the higher number should be positive. To continue, W plus 31 is equal to 0. W minus 26 is equal to 0. So you subtract 31 to both sides. You'll get W is equal to negative 31. Add 26 to both sides. You'll get W is equal to 26. Therefore, Wendy is indeed 26. Irene is 26 plus 5. That is 31. So that's it. We're done with an age word problem. And lastly, let's go with an error analysis word problem. So for error analysis, it doesn't have to be complicated. Basically here, you can just have an example and then give out different answers. So let's say that we want a factoring word problem. Let's say that the problem is as follow. Like we want this to be factored. Let's just make an easy example. Let's say x squared minus 36. So if you want an error analysis, you should have at least 2 people involved. So let's say Sugi says that the factors are as follow. X plus 6, x minus 6. While Irene says that the factors should be x minus 6 and x minus 6. So let's just have that as a given for this error analysis. So we can create a word problem such as this one. Irene and Sugi are collaborating on a pair work activity involving difference of 2 squares. Given x squared minus 36, Irene said that the factors are
x minus 6 and x minus 6, while Suji said that it should be x plus 6, x minus 6. And then, when you're doing error analysis, the final question will simply be something like this. Between the two, who is correct? The beauty about error analysis is at times, you don't actually necessarily need to put out a long solution. Instead, you focus already on the given and the pattern. So, let's say we have x squared minus 36. We can say that this is a difference of two squares. And we should go back to the pattern. Basically, that's the answer here. The pattern for its factors should be one positive and one negative. So basically, that's the important part. I mean, my writing is incomplete, but my explanation is complete. So just listen to it carefully. So again, one is positive and one is negative. So therefore, if it's an error analysis, you point out who is correct. Therefore, Sugi is correct. So in error analysis also, the beauty in that is you can point out or you can make use of the answer in the perspective of the one who got it incorrectly. So here, my answer is in relation to Sugi, but you can have an answer in relation to Irene. Like, since the pattern should be positive, negative, Irene is wrong because she gave both negative for the factors. As you can see here with negative 6 and negative 6, or minus 6 and minus 6. So that's it. So we have discussed error analysis, we have find the Aegis, consecutive pages, we even have area of a square, and area of a rectangle for our word problems. And that's it. And I hope that this helped out in you creating your own word problems involving factoring polynomials.
And that ends the so-called pet orientation. I don't know if I'm still gonna make more of these, but maybe I will, maybe I won't. But maybe this is where the outro becomes apropos of sorts. Well, in case you don't see me, good morning, good afternoon, good evening, and good night. Peace out. Respect.